Hello, welcome back to my channel, welcome back to SRE Chronicles. In today's video we will talk about special permission in Linux. But before we get started, please subscribe to my channel, hit notification bell, like and comment. So, in addition to standard read, write and execute permission, Linux provides special permission bits that modify how executables and directories behave. These are commonly used in multi-user environments and enforce controlled privilege behavior. So first option, SUID, set user ID. When SUID bit is applied to an executable file, the program runs with the effective user ID of the file owner, not the user who launches it. This mechanism is typically used for programs that require elevated privileges to perform special tasks. How we can set up user ID? By using chmod u plus s, set user ID and file name. So let's bring example chmod 4755 USR bin password. So this is not permitted. Sudo. Let's check ls-la usr bin password. And we see set user ID is setting. In this case, the password binary runs with root privileges, allowing regular users to change their password securely. So, as in the user execute position, next option, SGID, set group ID, set group ID. The set group ID bit has two different behaviors depending on whether it is applied to a file or directory. On an executable file, it runs with the file's group permissions. On a directory, newly created files inherit the directory's group instead of the creator primary group. This is especially useful for shared projects and directories. For example, ls, so chmod group plus s file.tx, ls minus la file.tx. Execute. So s appear in the group execute position here. Let's bring other example with numeric format chmod 2775 and test 2775 test ls minus ld test, and we see s group set group ID permission for folder. Other option, sticky bit. When the sticky bit is applied to a directory, only the file owner, the directory owner, and the root user can delete, rename, or rename files inside that directory. This is critical for shared public directory, such as, for example, TMP. So set sticky bit using chmod plus t and our test folder ls minus ld test. In the sticky bit appears T in the others execute position. You can also set by numeric format chmod 1, for example, 777 test ls minus ld, and we see T, and read write execute, read write execute, read write execute. Summary: special permissions for xx SUID set user ID, 2 xxx set group ID, and 1 xxx sticky bit. These special permissions bits extend the Linux access control model, enabling control privilege elevation and structured collaboration in multi-user systems. So that's all for this lesson. Thank you. Don't forget to subscribe and hit notification bell. See you in the next video.